Okay, next, there will be a presentation of Team Icebreaker with the title Proposals for the Development of the Digital Navigation Aid System of the Northern Sea Route utilizing the GIS-based Arctic Risk Map. Please come onto the stage.
Humanity has changed the center of trade and power by opening new routes. And now it's time to bring change again, navigating beyond the cold ice and treacherous waters, the Arctic. We are Team Icebreaker. We are moving forward to ensure safe navigation through Arctic waters. Our mission is to develop safe and efficient Arctic routes by providing solutions through data sharing and innovative platforms. Team Icebreaker, shaping the future of Arctic navigation.
Opportunity comes when we overcome risks, and hardships are easier to overcome when done together. Good day, honorable judges and fellow delegates. We are Team Icebreaker, and it is an honor to be presenting to you our ice-breaking proposals for the development of the digital navigation aid system for a safer voyage in the Northern Sea Route. Next. Today, climate change is opening the Arctic both physically and as an opportunity. However, the harsh environments of the Arctic Ocean are not an easy task to overcome, even as the chances are turning in our favor. Our team focuses on overcoming the risks of Arctic navigation by the proposal of the development of the digital navigation aid system of the Northern Sea Route, which enhances the e-navigation IMO is currently progressing with the integration of additional safety features, such as radar mapping information, including ice data from vessels. The integrated information collected from all users and regional flag states will benefit us all by a more safe and more secure shipping. The agenda is in the order of introduction, problem analysis, solution, conclusion, Q&A. Now, introduction. The importance of the Northern Sea Route and its risks. Conditions are being created for ships to venture into the Arctic Ocean. Due to global warming, the Arctic Sea is ever decreasing, while the construction of stronger icebreakers are increasing the feasibility of assessing the Northern Sea routes, along with growing international interests. The Northern Sea Route offers three main advantages. First, it shortens the trade route between Asia and Europe up to 46%. Second, the Northern Sea Route offers a safer alternative compared to traditional routes from threats such as piracy and terrorist activities. Third, the Arctic is rich in natural resources, holding billions of barrels of oil and natural gas. This will lead to extensive exploration and exploitation of the area. Due to the aforementioned advantages, the use of Northern Sea Route has been increasing every year. The data on the screen shows the Northern Sea Route transit in 2023. The improvements in extreme conditions and continuous growth in transit volumes present clear opportunities and favorable conditions for the use of this route. Now I'm going to talk about risks. The Arctic Ocean poses navigation risks due to the constantly shifting ice cover, which makes navigation impossible at times, and the movement of ice floes that can damage ship hulls. Additionally, there is a lack of depth and navigation data, the inability to request rescue via satellite equipment, and the inability to access real-time information on nearby ports. According to Allianz, the research, 156 accidents have been reported from 2000 to 2020, of which about 37.2% in total were due to wreck and stranding, climate, and ice contact hull damage. Considering the risks in voyaging the Arctic seas, the IMO has strengthened regulations through the implementation of the Polar Code since 2017, and additionally the e-navigation strategy implementation, Update 1, MSP 13 for ice-covered waters navigation. However, despite the IMO's aforementioned efforts, ships navigating the Arctic region continue to experience maritime accidents. In 2021, a fleet of 21 Russian cargo ships ran aground due to a failure in glacier prediction. In 2018, a training vessel ran aground on a reef due to a lack of depth information. Now, why do these accidents keep happening? My next colleague conducted a detailed analysis of the current reasons for the maritime accidents and our solution for the matter.
Now, I will present to you our team's problem analysis. The primary cause of ongoing maritime accidents is a lack of adequate information. The first issue is the limitation of ice data. The IceStat 2, which provides essential information on the thickness and distribution of Arctic ice, offers data only once per day at a resolution of a 25-kilometer grid. Norway's Baronwich, an ice navigation support application, provides ice information on a 20-kilometer grid every 6 hours. However, with such resolution and infrequent data, it is difficult to sufficiently capture ice flows that could potentially impact vessels. As a result, the current data is insufficient for practical navigational support. The second issue is the lack of bathymetric data. While Arctic bathymetric data is primarily mapped by IBCAO, there are still numerous unexplored areas. The figure below shows significant regions within the Arctic with insufficient bathymetric data. Such incomplete information poses a risk to navigation safety. Moreover, IBCAO's data collection process, which aggregate data from multiple countries and organizations, is constrained by a resolution of only 400 meters, inconsistencies, and infrequent updates, all of which limit its use for navigation. The third issue is the lack of structural satellite data and evacuation infrastructure information. In an area above 75 degrees north latitude, satellite communications are limited. It causes the satellite-based GMDSS system proposed by the IMO to be non-functional. So, distress requests must be transmitted via radio signals instead. However, in zones where radio signals cannot reach the Maritime Rescue Coordination Center, communication relays from passing vessels become essential. These issues can be addressed with a digital navigation aid system developed through advancements in e-navigation technology, which requires the following functions. First, a function should be implemented to automatically map ice flows information detected by the radar of vessels navigating the Arctic, converting it into image data and sharing it in real time. This would enable access to high-resolution data on ice flows that satellites currently cannot provide. Recent developments in radar-based mobile mapping technology make this feasible. And with the expected launch of polar orbiting satellites and increased data sharing capacity in 2025, its application is promising. Second, a feature is needed for vessels navigating the Arctic to automatically share information on rocks or other hazards underwater detected by onboard sensors. The Arctic is poised to become a significant new shipping route. So, sharing specific information about navigational hazards among the vessels afloat is extremely important. Third, the ASBM satellite, launched in 2024, and set to provide polar region communication service in 2025, should be integrated with the GMDSS system to ensure the RESC request system functions effectively in polar region. Fourth, harbor management system should be linked with e-navigation to provide swift access to available harbors and pilot assistance during rapid weather changes.
It's an honor to speak with you today. My teammates' analysis of the risk in the Arctic and the quantitative method for safety navigation. Now, I will propose this finding to the IMO from a policy perspective. According to the IMO e-navigation strategy implementation plan, the following points can be identified. Let's take a look at highlight part number 2 and number 3. Number 2, number 3 say that the implementation of e-navigation is not something just wait for someone else to create. For the implementation of e-navigation, we, as a navigator of the sea, must continuously request and demand the necessary requirement. Now take a look at the highlighted part number 4. Number 4 means that the e-navigation is not fixed, but rather has a dynamic character that must evolve in line with the time. Let's look at the highlight part in number 7 and number 8. As you can see, the IMO require the implementation of e-navigation to be adaptable, changing with advances in technology, users' needs, and emerging trend. The resolution MSC points 467 specify that maritime service should be proposed using the template in Appendix 1. The left template is the draft description of maritime service in the context of e-navigation. I have prepared the key section of the format. Number 7, users need, and number 8, information to be provided. Let's take a look at the right table. We as a team want to suggest crowdsourcing of ice information, hazard zone, distress signal relay, piratage port information, meteorological information. We have also outlined the information to be provided in the table right on the far right. This all means information sharing for safety navigation in the Arctic Sea. Our requirements do not need anything new. It would be simple to align with the e-navigation that IMO is implementing as shown figure 2. E-navigation is expected to provide various maritime service, and one of which is the ice navigation service. The foundation of all maritime service is based on the S100 framework data model. Additionally, the information regarding glaciers, safety zones, water depths, and safety infrastructure is already available from various countries and organizations, such as WMO, IMO, and BIMCO. We argue IMO to encourage international cooperation to share information on digital navigation aid system. It's been a long morning voyage, but we are nearing the conclusion. Opportunity comes when we overcome risk, and hardship are easier to overcome when done together. IMO mission is to promote safe, secure, environmental sound, efficient, and sustainable shipping through cooperation. We will ensure the safety of the sailor navigating the Arctic Ocean by proposing development strategies for e-navigation in the context of the newly opening Arctic Sea. Thank you for your attention.
Thank you very much. Thank you, Icebreaker. Let's give them a big round of applause. All right. Like you said, what an ice-breaking proposals, and we will take a Q&A session right now. Yes, please.
Thank you. Your presentation is very interesting to me, especially because I was charged with developing the Korean e-navigation around the Korean peninsula. So anyway, you pointed out the importance of the e-navigation to provide some kind of currently lack of information to the vessels sailing around the Arctic and northern sea areas, right? Yeah. So, so you show some kind of examples that the vessel currently using the navigating systems, such as the Navtex systems. Navtex system is a kind of the shepherd boys and the wolf. For example, Navtex broadcast all necessary information to all vessels. So if I check the Navtex, when the Navtex give me some alarm to check, the information provided occurred in the Pacific area, but my vessel is in the Atlantic areas, such like that. So if repeated such kind of cases, the seafarers do not check the Navtex again, because they don't need such kind of information. The information is for the other areas. Then my vessel is now sailing in the other areas. So this is a very important point, the differences between the Navtex, which is the analog techniques based, but the navigation is based on the digital techniques, you know?
Yes.
Yeah. So in terms of the navigation technology, what kind of differentiated information servicing system compared to the current analog-based technology like the Navtex? Can you identify such kind of differentiated from the other analog-based communication system in terms of the navigation system?
Okay, thank you for your question. It is different that we suggest to accept new technology about mobile mapping system by radar. So then we can sharing image data about ice flows and drifting ice on site. So we can recognize that where is the hazard zone on site more specific.
Okay, thank you. Actually, the differentiated of the navigation services from the other current analog-based technology is to provide a customized services to a specific ships. So, for example, if there is some risk occurred right now, just in front of some vessel, the e-navigation service can provide this necessary and urgent information to the vessel at the spot, not broadcasting system. And my next question is that you pointed out some kind of importance of the data structure, for example, the S100 data structure, right? Yeah.
Yes, sir.
So what is the benefits or differentiated when we adopted S100 data structure and the sea navigating systems? What is the benefit, the most benefit, when the system adopted the S100 data structure? In terms of the navigation or the various navigation systems.
Thank you, sir. We believe that by using the S100 data structure, will bring us benefits as a framework or as a standard for the whole IMO to use. This S100 framework is widely used currently all around the world, and it is easy for users to adapt to the currently widely used systems. So we tended to use the S100 system.
Yeah, okay, thank you. As you explained now, the S100 data structure is a common data maritime structure. So in the maritime sector, so most of the maritime sector will use this data structure because as you know, there are many kinds of navigation system on board now at the time. For example, radar, AI system, Navotex, and the other meteorological system. There are many kinds of systems on board. So officials have to check several systems together when they navigate ships. But if you introduce or adopt this S100 data structure, they can check all information on a single system because they use S100 standard data structure. So they don't need to use no more the other system, only one system that can provide all kinds of different information. So that is the most beneficial point of the S100 data structure. Thank you so much.
Yes, you're right. We S100 data use the XML format. So this is our teammate make them system. You can see the glaciers, hazard zone, and so on. You can see that image.
Okay, thank you. Anyway, you just you did very well to explain the S100 standard and also e-navigation. Through this both technology of e-navigation and S100 data structure can change everything of the ocean sectors. Thank you so much.
Thank you for your comments and questions. And any other questions from judges? Okay, Dr. Gang, please.
Yeah, thank you for your very interesting presentation. Actually, as you mentioned, it's very important to monitor the exact position of drifting ice to ensure the safe navigation in Arctic areas. So in order to monitor or know the exact position of iceberg or some drift pathway, there are many academic or researchers are being carried out, especially as you mentioned, we are wanted to know to use satellite or other radar or numerical modeling, but nobody can endure the some question or some the technology is not safe to endure such kinds of safe the navigation Arctic areas. But can you examine the level of existing technology or new technology, as you mentioned, for detecting of the exact position of iceberg of Arctic area, to use such information at some e-navigation or other the navigation position alarm system? My question. Thank you.
Thank you.
1 minute left.
Okay, thank you for your kind question. Currently, right now, as you have mentioned, technology is not at that level of the real-time risk assessments. However, automotive cars and LiDAR technology is used right now currently on roads, on land right now. We take so many pictures of while as the cars are driving, and they are all implemented into one map, and those kind of technologies will improve our safety. Thank you.
Thank you. Unfortunately, it's time to end this Q&A session, so I'm gonna wrap things up. So once again, thank you very much, and everyone, please give them a big round of applause.